In the previous video, I have discussed about a stock exchange system. Here, I'll be discussing about stock trading app. We'll see how these stock trading apps are connected to the stock exchange system. How do we get the real-time price updates? How we place an order in these stock trading apps and the order is moved to the stock exchange system.
Let's start with the functional and non-functional requirements. Functional requirements, the first one we have is users will search and fetch stock price details. The second, the system connects with the stock exchange to fetch the stock prices. Next, users should be able to see stock price updates in real time. So here a few things we have to think about is the prices are coming from the stock exchange. So we have already discussed about the stock exchange system design in our previous video, but from stock exchange basically we are getting the stock prices. So when user is coming to the stock trading app page, user will be able to see the stock price for the particular stock. But when the user is on that page, then whenever the price is getting updated, so that price update should come to that page immediately in real time. Next, placing a buy or sell order. So orders are forwarded to stock exchange. So the stock trading app is basically sitting in between the client and the stock exchange system. It's taking the buy and sell orders from the customers and it is forwarding it to the stock exchange. Next, support for limit and market order. So there are two types of orders. So market order is basically when the customer wants to buy or sell the order in the market price, and limit order is when one limit is set. If the price goes beyond that limit, then only it will be sold or bought. Next, sends the order details to stock exchange. No need to handle buy and sell order matching and match fulfillment. So if we have seen the stock exchange system design, so there we have seen we have to match the buy order and sell order. The stock exchange system picks one buy order and sell order and tries to match that. Then after the match has to be executed. Means the payment has to be the money has to be deducted, right? So these things we don't take care of in our stock trading app. We just take the orders from the customers and we send it to the stock exchange system. And the last requirement we have is users can view their past order details. This is a simple one. Next, let's discuss about the non-functional requirements. Highly available for search and get. So viewing the stock prices should be a highly available operation. It's okay if you are not getting the very latest data. We'll see how much consistent we can make it, but this viewing the stock prices should be very highly available operation. Next, highly consistent for order placement. So the order placement should be highly consistent, but what that means? So let's say the money is deducted, the payment is successful, but the order status hasn't changed, right? Order has failed. So this kind of inconsistency should not happen in our system. Next, scalable to a large number of users. So of course, we will be designing the system in such a way that it can be scaled to a large number of users. Next, read-heavy system. So the price views are often more than the actual orders. So of course, users will view the stock prices more, and maybe let's say 5% or 10% will result in the actual orders. Here next I have assumed few numbers for our scale. So this may not be the actual current numbers of a stock trading app, but this I have considered for our design here. This is more or less realistic. So let's say 100 million total users. 10% of that is daily active users. So that means 10 million daily active users. Stock price views. Consider per user 10 stocks and 20 times. That means each on an average each user is seeing 10 stocks and like 20 times he is visiting for one stock. So basically our views will be 10 million into 10 into 20 views per day. So this is 2 billion views per day. That 2 billion is 2 into 10 power 9 views per day. Now if we assume that 10 power 5 views, 10 power 5 seconds in a day approximately, then 2 into 10 power 9 divided by 10 power 5 by views per second. So that is 20,000 views per second. So this is the QPS or query per second, which is huge. Next, 10% of views result in orders. So among the QPS, query per second, only 10% considered is resulting into actual order placement. So that means 2000 orders per second. That is the TPS or transactions per second. So that is also huge, but you see this the system is read heavy. And also, like, this is the normal calculations we have done. We should consider some peak load, right? Consider around 5 times peak load. So then this will be 5 times all of that. So here I have now discussed about few APIs. We'll see later if we have to change few APIs, we'll come back and change. So the first one is viewing the stock prices. We can have one API like get/stock prices. This will give some consolidated view of the stocks, like current stock price for few stocks. Like we can have the result in paginated way. I have not I have not added the query parameters for pagination and sorting, but we can add that. Next, get/stock prices for this current symbol, and let's say time range is, let's say customer wants to see for the last 1 hour or last 1 day or 2 days, what are the stock prices, right? So this we can do using this API. Next, we have a place order API. So that will be a post API, post/orders API. So what it will take as a payload? It will take the order type, whether it's a buy order or sell type, buy order or sell order, type, whether it is a market order or limit order, stock ID or symbol, stock symbol, quantity and amount. Next, view past orders. So customer will be able to view the orders they have placed. So there can be get/orders. So that is for all the orders the customer has placed, and also get/orders for a particular symbol. So in all of these APIs, we have not added the user details in the payload. Of course, because the user details we don't add in the payload. User details is always added in the header section as a JWT token or session token. So that's for the security reason, because otherwise anyone can pretend to be an user, right? Authorized user. Next, we'll discuss about the high-level design of the system. So, of course, we have seen the scale of the system. It's huge. And, of course, there are two main operations, price, like the viewing the price and order placing. So, these two can be scaled separately. We'll go for a microservice-based architecture, so that even if the order management service, we are having two services. First of all, one is the price service and one is the order management service. Price service is responsible for viewing the prices, and order management service, as the name suggests, for placing the order, also for the viewing orders. Now these two services can be scaled separately based on their requirement. We will also have one API gateway, because API gateway takes care of authentication, authorization, rate limiting, API routing, load balancing, and all these stuffs. Now, first let's discuss about the price price service, where using that users will be able to view the prices. So how the prices will come to our system? First of all, so there is a stock exchange system. So this is the black box now here for this discussion. Now we'll have some gateway that will be used, that will fetch the data from the stock exchange system. So this is the fetch, this will fetch the price from the stock exchange, and let's say it will store it in this stock database, and this price service will fetch the stock prices from this database. Now what type of, like, first of all, what should be the data model for this stock database? We'll have a stock tables. We need to store the stock ID and the symbol, and for each timestamp what are the prices, because here we are storing all the price changes for the stocks, right? For each timestamp what is the price, so that we are storing. So what type of database do you think will be good for this stock database? So we are storing a timestamp, for each timestamp the price, and then the requirement is we can view the prices based on some time ranges, right? Let's say 1 hour, for last 1 hour, 1 day, 2 day, and all this. So for this requirement I feel one time series database will be good. Now next one is order management system. So using this service we'll be able to take the orders from the customer. Now the order management service will send forward the order request to this stock exchange via this stock exchange gateway. So the order management service will send the orders to the stock exchange gateway, and stock exchange gateway will forward the orders to the stock exchange system. Now here also we are storing the order details in this database. This is the order DB, and what we are storing here, the ID, the order type. The order type is basically this is a buy or sell order. The type, it's a limit order or market order. The quantity, amount, status. The status can be whether the order is processed or it's in progress, whether it is failed or it's or successful, and this type of status. And the exchange order ID, because the stock exchange system also will store the order details in their own database, right? So that exchange order ID also will be storing here. But how will get the exchange order ID? So when the order management system will forward the request to the stock exchange gateway will forward the order to the stock exchange system, and stock exchange system will respond with the exchange order ID. That exchange order ID will be storing in our database. Now one question might come is, why do we need to store the order details here in this system, in the stock trading app system? Because stock exchange system is also storing the order database or storing the order details in the order database, right? So there are a couple of reasons for this. We should store the order details in this stock trading app system. First of all, there is this view orders requirement we have, right? Customer would want to see the order details they have already placed. So for each of these view orders request, it doesn't make sense to every time go to the stock exchange system, calling the stock exchange system to fetch the order details, right? It's very easy to store in our system, and we can send the data like we send data from our local database. That's one reason. Another reason can be for reconciliation purpose. So if at the end of the day we have to do some reconciliation, like how much orders we have received in the stock trading app, how much we have forwarded to the stock exchange system, how much failed, how much succeeded, and all this type of calculation reconciliation if we want to do. For that we need to store this data in our own stock trading app system. There are other reasons also, we'll come to that later. Next, we'll deep dive into the view price section. Consider the view price section here. So here stock exchange, from stock exchange gateway. Stock exchange gateway is basically fetching the price from stock exchange system and storing in the stock database. And price service is fetching the data from the stock database. But see, there are few things. First time when the customer is coming to the price service, the customer will fetch the full stock details from the database. That is fine. But when the customer is on the page, then also whenever the price is changing in the stock exchange system, that data should come directly to the customer page, should be like sent to the customer page in real time. That was our one of the requirement, right? For that, how do we send the price updates in real time to the customer? So that's the first thing. So for that, we are using SSE or server sent events here. Now we can discuss why we need SSE. Why not polling, WebSocket, or we have several options, right? Polling, WebSocket, or server side events. We'll discuss this. So for from this, let's say the user is in the search page, right? So there, to get the real-time price change updates, one thing customer can do or client can do is periodically poll the service, right? So that's one of the problem here is again and again the client has to poll. And so next option is WebSocket. For WebSocket, basically we create a bi-directional connection between client and the service. So, but here in our requirements, we don't need a bi-directional connection, right? We only needs to send the price updates from the service to the client. From the client to service, we are not sending anything, right? So WebSocket is useful in bi-directional communication, like a chat application. So here, that's why we are going for a SSE or server-side events here. Now, how the real-time updates the price service will get? So the stock exchange will fetch the price from the stock exchange system, and it will store in the stock database, right? Also, it can store it in some queue, message queue, and from there, price service can read from this queue and send it to the client. Now, one improvement we can do is instead of using a queue like Kafka queue, we can go for a lighter approach like using a Redis PubSub. So Redis PubSub is very lightweight and it's a push-based mechanism. So the stock exchange gateway will fetch the price and it will put it in this Redis PubSub, and the price service consumers will subscribe to the particular channel and then will send it to the client. Now also, how the stock exchange gateway will get the prices from the stock exchange system. So that also will depend on the contract we have from the for the stock exchange system. The API is exposed for the stock exchange system, whether we have SSE support for the stock exchange system or not. So it's ideal so that the stock exchange system also send the price updates using some SSE, using a SSE or server side events. So it's basically then the flow becomes very smooth. So the stock exchange system sends the price updates using SSE. Stock exchange gateway puts it in this Redis PubSub and also stores it in the stock price, stock DB, and then this price changes is pushed back to this price service, and then the price updates are sent to the client. Next, we'll deep dive into the order management. Now, in the order management, we saw earlier that we are storing the order details in this order database, and we are sending the forwarding the order details to the stock exchange gateway, where the stock exchange gateway is forwarding the orders to the stock exchange system. Now, what can happen is, let's say if this stock trading app is getting lots of orders, and of course the stock exchange system will have its own rate limiters and all, right? So these two can't scale together, right? So we need some kind of buffering between these two, like from the order management system service to the stock exchange gateway. We'll add one queue here. So the orders will push into this queue, and stock exchange system will read from this queue and push it to this stock exchange system. Now, when the stock exchange gateway forwards the order to the stock exchange system also will need some time to process the orders, right? Because stock exchange system has to match a buy order and sell order, then it has to execute the match, and all this will take time. So what the stock exchange system can do is, when the stock exchange gateway will forward the orders, it will send the status as accepted, and it will send the exchange order ID, the exchange order ID created in the stock exchange system. Next, this exchange order ID will be moved to this order database. This exchange order ID will be updated in the database. When the order will be successful in this or failed in this stock exchange system, the status should come back to this our system, right? For that, we can give one webhook, so that using that, stock exchange system can update the status of the order, and the status will be again updated to this order database. So let's see now if we have covered all the requirements we have. So users will search and fetch stock price details. Yes, the system connects with the stock exchange to fetch order stock prices. So users should be able to see stock price updates in real time. Placing a buy sell order, orders are forwarded to stock exchange. Support for limited market order. Sends the order details to stock exchange. No need to handle buy and sell order matching and match fulfillment. Users can view their past order details. Right. So all this we have covered. So like one thing is, the viewing the order is basically this database. If we have to shard or we have to partition, we should partition it based on the order ID, because we have a requirement of viewing the orders, right? So we should partition the database using order ID. Next, non-functional requirements. Highly available for search and gate, highly consistent for order placement, scalable to a large number of users, read heavy system, price views are more than actual orders. Let's see in our final design. So yeah, first one is price service. The viewing the price is highly available, because this service will be auto scaled, right? So there is no single point of failure we can see here. And this database also, this we are using a time series DB which can be scaled properly, and the price details also is going through this async flow and sent to the customer in real time, and this is not highly consistent, but it's highly available. Next, order management service. This is highly consistent, because we are storing the orders here, and this is the exchange order ID we are maintaining. So one thing we have to keep track of is, once the order is accepted by the stock exchange system, stock exchange system will provide one exchange order ID, right? So that is, then we are done here, because the order can be failed, successful, or any other, can remain in any other state, but that will be handled by the stock exchange system, because in this system we are just forwarding the order to the stock exchange system, and any reconciliation and anything will be done using this exchange order ID. If the order is not accepted by the stock exchange system, then we have this queue, right? So we can retry that order again and again. So that also should be a limit for that. So yes, and this services also will be auto scale. The database we have already designed will partition it based on order ID. So I think yeah, our system is highly scalable, fault tolerant, and yeah, with this I think we are done with the system design here.